Electrical force. This is a third section in under forces, and as you notice, that forces are rather lengthy because they're the basis of almost everything that we do. So we're going to be starting to talk about electrical forces today. And one of the first things that you need to know how to do is scientific notation. And basically what scientific notation is, it's a shorthand method of writing either very small numbers or very large numbers. And if you take a look here, there are some examples. Like this number, you wouldn't want to keep writing this number over and over again. Alright, so what you do is you're always going to have just one digit to the left of the decimal. So it's going to be 1.23. And then what you do is you count. Alright, and so we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, to get to that point where you're going to put your decimal. So it's going to be written as 1.23 times 10 to the 13th. Now, how do you know whether this exponent, 13 here, is positive or negative? If you are moving your decimal to the left, alright, that's going to be a positive number. Like the way I usually think of it is, if you're talking large numbers, they're positive. If you are talking about a number less than 1, you're talking small numbers, and they're going to be negative. Like this one here. Alright, you have all these zeros, but you have to come to, you finally get to a non-zero number. And you notice here that you have 5, 6. It's going to be 5.6. Alright, ignore that comma there. So 5.6. And what you're going to do is you're going to count from the decimal. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you move to the right. So you're going to end up with 5.6 times 10 to the 9th. Alright, that's all there is to scientific notation. Okay, a problem that a lot of students have is using the calculator. And you need a scientific calculator, and it should have on there an EE or an EXP key. Okay, and so you need to find that on your calculator. Sometimes it is what is called like a secondary function, which means that it can be written in a different color, or it can be written above the key. And then you usually have a button that is in the upper left hand corner or at the top of the calculator that is in a certain color, and they match. So if you want to get to that particular colored symbol, alright, EE or EXP, they're going to match that key up on top. It might say second mode. It has a variety. It might say inverse. Okay, it has a variety of things that you might find on a calculator. So let's take a look. If we have 6.00 times 10 to the 13th, we want to put it in the calculator, what you do is you put 6 and then hit the decimal 00. Then you need to locate the EE or EXP key. If it is a main key, in other words, it's right on the button, you just hit the button. If it is written above the button or in a different color, alright, then you have to hit that key up on top of the calculator pad to access it. Then you hit it. Alright, and then what you do, you don't put times 10. Alright, that's the big mistake that most people make. You don't put in the times 10. You put in whatever the exponent is. Okay, in this case 13. And so when you look at the display on the calculator, it should be 6.00 with an E. Depending on the calculator, it might be a big E, it might be a small e, and then 13. Now, if you wanted to make that a negative 13, alright, let's say it was 6.00 times 10 to negative 13. On most calculators, you're going to hit the minus sign. There should be a plus minus button. Alright, and it has both plus and minus on it. It's not used for addition, not used for subtraction. Alright, you hit that, and it will put a negative right in here for you. Okay, so that's how you put it in your calculator. It's a good idea to try that. Alright, make sure that you can do that. But that's what it comes up as. Once you learn to use it on the calculator, they're easy. Alright, and you won't mind doing them at all. It's a lot easier than if you're going to do them by hand. Okay. If you are doing them by hand, there are several rules that you need to follow. Okay. Uh, the exponents, if you're doing addition and subtraction, the exponents must be the same, and if they're not, then you have to adjust them to make sure that they are the same. Multiplication, you are going to add exponents. And in division, you're going to subtract them, and it's from the top down. I would say doing it by hand is a good way of checking your work. What if you have a problem with your calculator? I remember when I was in college, it's a long time ago, but they had just first come out with the solar calculators. And the professor did not turn the lights on in the room. And what happened is they operated, but they operated incorrectly. I'll tell you what, there's a lot of fuss that day, let me tell you. All right, so it's a good idea that you can look at numbers and you can tell if they're right. All right, this link that's listed here, this is a good link. You can practice writing exponents like what we did initially. You can practice any of your arithmetic skills, and my suggestion to you would be have your calculator there. Use your calculator, do it by hand, practice both of those so that you can get it done. It's not a difficult skill, but it is an important skill that you're going to continue to use. Alright, so it's one of those things, if you're planning on taking any more science courses, scientific notation is a must. Alright, let's take a look at a law that uses scientific notation, because we're going to be looking at really big numbers. Alright, and it's Newton's law of universal gravitation. Now, the reason that I am showing you this law is we're going to see another one with our next PowerPoint for your next assignment that talks about another law that is what I call the sister law of Newton's law of universal gravitation. We're going to deal with big numbers here. That one will look almost the same as this law, but you're going to deal with really small numbers. What it basically does is it talks about the attraction between objects, but typically we're talking about big objects like planets. All right, and we know that there's a gravitational pull, and that in space, you have that interaction between the planets and anything that happens to be in space, including rocket ships and so forth, asteroids, meteors. Okay, so we're going to take a look at it. This is your gravitational force. All right, that G describes that. The capital G is what is called a constant. It's the gravitational constant. All right, when you use constant, that means that it's like pi. Pi has 3.14. Okay, well, G is a constant, and there is a number that you put in place, which we'll talk about in a minute. And then you have M1 and M2. That means you have two different objects. Mass 1 for one object, mass 2 for another object. And then here you have d squared. D is distance. All right, basically it is the distance between the two objects from their center to center, and then you square it. And when you perform all the operations here, it's going to come out as a gravitational force. Now, the gravitational force should come out to things like a Newton is what we normally measure force in, or a pound. And I believe we're just going to deal with the metric on this one. All right, this is just to basically review some of the things I've said. Tells you how much force there is between two large bodies like the Earth and the Sun, or the Moon and the Earth. We know that the Moon has attraction. Why else do we have tides? They also talk about people's behavior during full moon. All right, that I'll tell you what, that gravitational attraction, it does have an impact. As the distance increases between the object, gravitational force decreases. So as an object gets further and further away, all right, there is less gravitational force. When we think of NASA and the rockets, they have to fight the gravitational force, and as they go up higher, it gets less and less. All right, let's take a look at units. All right, gravitational force, we're going to measure it just in newtons. The constant, which means every time you see this, you don't have to solve for it. This is the number, 6.67 times 10 to the negative 11. All right, newtons times square meters over square kilograms. Mass is going to be measured in kilograms. Distance is going to be measured in meters. All right, and what you're going to see is that when you put this in the equation and you do the operations, all you're going to be left with is newtons. That's why this unit is so big. All right, here's a picture. We have, look at, you can't see gravitational forces, but you can see all the different objects that are in the sky. And they all have interactions between each other. All right, but the ones that are further away, all right, you have less interaction, if any, depending on how far. All right, but that is a pretty picture. Okay, let's take a look at a problem. And my suggestion is you have to be very orderly about doing this. All right, I always suggest that when you do word problems that you list everything that you have. All right, here we have 5.98 times 10 to the 24th kilograms, and it has the mass of the moon has 7.36 times 10 to the 22nd kilograms, so it is less massive. And the distance between is 3.85 times 10 to the 5th kilometers. What force does the Earth exert on the moon to keep the moon in orbit? Well, the first thing you have to notice with this problem is what we talked about here with the gravitational force. Notice that it is newtons times meters squared. All right, so that means that this up here in kilometers, that has to be changed. All right, and kilometer means 1,000, so that means you're going to add 3 zeros onto it, and when you do that, you're going to get 3.85 times 10 to the 8th meters. All right, let's do this. So for G, we put in the constant. Put in one mass, that's the mass of the Earth, mass of the moon. This is the distance between the moon and the Earth, and then we square it. What I normally do when I put stuff in my calculator, and you can do it as your math teacher says, but this is one of the things that I've always done, is with a lot of these bigger equations, I like to start over here. And what I'll do is I will multiply these, and then I will square this number, or you can do divide by 3.85 times 10 to the 8th, and then divide again by 3.85 times 10 to the 8th. I suggest you hit the equal sign in between though. All right, what I want you to do is practice that and make sure you're getting this number, okay, to make sure that you're putting it in your calculator correctly. All right, well, what about attraction between, other areas, like, for example, forces between people? All right, the force between these two people is relatively small. So therefore what's happening is we really can't measure it. We don't have the technology at this point in time. But is there attraction between objects? Yes, there's attraction between these people and every single object that's in that room. Alright, so I kind of answered that question for you, so we'll go on. Everything has gravitational pull. The more dense, the greater the pull. Okay, that's one thing to remember. And then objects on Earth are so small that the pull is almost undetectable. All right, and that wraps up our scientific notation and our law of universal gravitation. And I believe there's a worksheet that follows. All right, have a great day.